Algebra 2 state sample question number 13. After sitting out of the refrigerator for a while, a turkey at room temperature, 68 degrees Fahrenheit, is placed into an oven at 8 p.m. When the oven temperature is 325 degrees Fahrenheit, Newton's law of heating explains that the temperature of the turkey will increase proportionally to the difference between the temperature of the turkey and the temperature of the oven as given by the formula below. So Newton's law of cooling or heating, it can work both ways, is basically, when you place an object of one temperature in an environment of a different temperature, the object will slowly get closer and closer to the environment's temperature at a rate that can be predicted by this formula that Newton created. Now, it's one of these ugly formula questions, like those mortgage questions and things like that, but we always tell you what the pieces are. So they'll always give you this kind of key to go along with this. They never expect you to memorize this or anything like that. So T that it starts with is the temperature of the object after T hours. So capital T is the temperature of the object, and lowercase t is T hours. So like in 2 hours, the temperature is 70 degrees, something like that. Um, of course, that's not really, well, we'll see. Um, T, T of A is the temperature surrounding the object. So that's the temperature of the environment, in this case, the oven temp, which is 325 degrees. T of 0 is the initial temperature of the object, and what this question doesn't say is the turkey was sitting in a turkey at room temperature at 68 degrees Fahrenheit. So I guess the turkey was sitting in the room long enough that it became the temperature of the room, 68 degrees. So that's the initial temperature of the object, um, when it's placed in the environment. As it's being placed in the oven, it's 68 degrees. T is the time in hours. They didn't say how long. We may be finding that. T is the temperature of the object afterwards. K is what's called a decay constant. So the first question they give us, and this is a multi-part, or this would be probably a part four, I would guess. Maybe a part three at least, but maybe a part four. I guess it could be a part three, but we'll see. The turkey reaches the temperature of approximately 100 degrees Fahrenheit after 2 hours. So that's the temperature of the object, and that's how long it took to get there. So they're giving us this, and they're giving us this. Find the value of K to the nearest thousandths, and write an equation to determine the temperature of the turkey after T hours. So first, find the value of K. So they gave us something for the T of nothing, just the temperature of the object after 2 hours. So the setup would look like 100 equals T of A is the temperature of the oven, 325 plus parentheses the temperature of the object, 68 degrees when it's placed in the environment, minus the temperature of the environment, 325 degrees. So this temperature of the oven goes in two spots. It's the only thing that goes in two spots. And that is times E to the negative K times T for hours, and they tell us that's 2 hours. So this is what your setup looks like right here. You'd probably get 1 point on a Regents just for putting that in properly like that. But now let's clean it up a little bit. First we can, let's keep it 325. First thing I would want to do is clean up this 68 minus 325 here. And that's going to give me a negative value. So 68, let me get out of this graph here. Still clear that. 68 minus 325, and it's going to give us a negative 257. So plus negative 257 times E. And instead of negative KT, I'm going to put the negative on the 2. Negative 2K. Because these are three things all being multiplied. It's like negative 1 times K times 2, so I can rewrite it like that. You don't have to, but I think that will just make things a little bit easier. So we're solving for K, and K is an exponent, and right there, we've been in this course long enough that you should know anytime we're solving for an exponent like this, it's a big hint that you're probably going to need logs. And the fact that there's E here means we could also do a natural log thing. So solving for that exponent. All right, well, we need to first isolate the base. The base of this exponent is E, not the negative 257, and certainly not 325. So I want to remove those pieces first. First, I'll remove the 325. So minus 325, minus 325. And they're not giving me nearly enough space in here to do this question, but I'll try to cram it in where I can. So first, 100 minus 325 is negative 225. So let me write that next step over here. Negative 225 equals negative 257 times e to the negative 2k. And then lastly, this negative 257 over here is being a coefficient of the base. It is not the base. If it was like this, then it would be the base. But it's not in parentheses with that e. So I can, since it's a coefficient being multiplied by e, I can divide negative 257 on both sides to remove that. It's negative 257, negative 257. And this is where I'm going to start to get some pretty annoying numbers in my calculator. Negative 257. All right, and so we have a crazy long decimal here. I'm going to write it as 0.875 for now, but I'm going to use the whole. I like to do dot, dot, dot after it to remind myself that I'm not going to use 0.875. I'm going to use the whole number in my calculator, e to the negative 2k. All right, now the base is isolated, so you can do logs. You have two choices here. You can do logs, which always works out to be that negative 2k, or we'll do this, log answer, which is that 0.875 dot, 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 divided by the log of the base, which is log e, that equals negative 2k. Or, because it's e, we could just type in ln 0.875 dot, 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 equals negative 2k. Because dividing by log base e is log base e is a special concept we call it the natural log. So we could do ln of that. Because if you were to convert this in logarithms, it'd be log base e of 0.875, and log base e is simply ln. So when you're solving for an exponent attached to e, you could just do ln of the answer piece over here equals the exponent. But if you want to stick with logs, because if this is base 7, then it would have to be log of that divided by log of 7. There's no other shortcut. But you definitely need to be prepared for this. Now, the reason why it's okay that we have this long number is because that's the first number I need to type in. And so I'm going to do ln. Sorry, I need to tap on my arrow there. And I could do ln second answer, and it grabs that entire decimal. Because if I were to type in ln of 0.875, I'd get something slightly different. And I'd never want to round until the very end. And so that's what negative 2k equals. So lastly, in the end, I need to take that and divide by negative 2 to get a value of k, and now I can round to the nearest thousands. And it goes tens, hundreds, thousands. So divided by negative 2 is 0.06648, but to the nearest tens, hundred thousand, that's 0.066. So k equals 0.066. And that's the first answer to a very long question. Find the value of k. So like that's why this has to be a part 4, because right there, that's longer than a standard question right there. Like if it was just that, that'd be maybe a part 2. But the fact that they want this attached to it, this has to be a part 4 if they're asking a question like this. But something students forget a lot of times here is it says find the value of k to the nearest thousands. We did that. And write an equation to determine the temperature of the turkey after t hours. We didn't do that yet. Basically, what they want us to do now is write an equation like this up here as t being t, but now that we know k, to write an equation that we can use for another question, which they're going to ask down here. So that equation would be the temperature of an object equals 325. You could do plus, you could still have the 68 minus 325 in there, or we could keep it simplified to negative 257. You actually don't need the plus here, you could just go straight to the minus, but either way, e to the negative 0.066 t. Because remember, it's negative k t. We found k. So negative k times t. So this is our second answer to this first question. We found k and we wrote an equation for t. Then, Determine the Fahrenheit temperature to the nearest degree at 3 p.m. So now that we have an equation, 3 p.m. But T is time in hours, so we're not going to put 3 here. It was put in at 8 a.m. So how many hours later? 9, 10, 11, 12, 1, 2, 3. That is 7 hours later. Let me do that again. So we put it in at 8, so 8 to 9, 10, 11, 12, 1, 2, 3. That is 3, 6. That is 7 hours later. So 7 hours. So T equals 325 plus negative 257 times E to negative 0.066 times 7. And the good thing here is we could just type this into our calculator. We're not going to have to do anything else. So 325, let's do minus 257 E raised to the negative 0.066 times 7. We get 163 degrees, and we want to the nearest degree, so that is 163 degrees. And then, as always, we want to ask ourselves, does the answer make sense? An 83-degree turkey put in a 325-degree oven will get to a temperature of 163 degrees 7 hours later. Of course, the temperature is going up, so that's a good thing, and that's that. So a long question for sure. Most of it is just on finding k because it involves substitution and rearranging and solving for an exponent with logs or ln. And then a lot of people forget this step where it says write the equation for t. And so when they say determine the equation for t, you know, like we're going back to, you know, we want a general equation we could use then if we had a different value of t other than the 2 hours they gave us in the first part, and then use that equation. So there's really 3 different things here that, again, this exact question would have to be a part 4 worth a lot of points on a Regents exam. All right, so a lot of stuff there, and that's it. See ya.